Consider the terms 3a and 10a. Since the terms are similar, they can be combined as 13a. So we have here similar literal coefficients, so we can add them. And then how about the terms 5a and 8b? Can we combine them? The answer is no. We cannot combine since their literal coefficients are not the same. As you can see, we have a and b here, so we cannot combine them. So let's go on to our examples. So we have 14x plus negative 8x. So what we are going to do, we just add 14 plus negative 8, which is equals to 6. And then we copy the literal coefficient. So the answer is 6x. Another example is negative 12xy plus 25xy plus negative 6xy. By the way, you can add monomials vertically or horizontally. So we have to add this first, the numerical coefficients. We have negative 12 plus 25 plus negative 6. The answer is 7. And then copy the literal coefficients since they have the same literal coefficients, which is xy. So the answer is 7xy. How about this one? 2x plus negative 3y. Can you add them? No, because their terms are not similar, so they cannot be combined. So you can bring it down, 2x plus negative 3y. To subtract monomials having similar terms, the numerical coefficients are subtracted as in signed numbers, and the literal coefficient is retained. Recall the subtraction rule. For all real numbers a and b, a minus b is equal to a plus negative b. So let's have an example. 8x squared minus 3x squared is equal to, we can rewrite this as 8x squared plus negative 3x squared. Therefore, the answer is 5x squared. Let's go on to another example. Negative 14ab minus negative 27ab. So as you can see, the literal coefficients are the same. We have ab here and also we have ab here. So they have one exponent. So therefore, if we change it, we have negative 14ab plus 27ab. The answer is 13ab. Let's go on to our last example. 56y minus 38y equals 56y plus negative 38 y, and the answer is 18y. Unlike the processes of addition and subtraction, multiplication of monomials considers not only the numerical coefficients, but also the literal coefficients. Some laws of exponents are important in multiplying monomials, like a squared times a cubed. So what we are going to do, we can expand this one, which is a times a times a times a times a. Or we can just add these exponents as a squared plus cube. So our answer is a to the fifth power. You notice that we can add this by having the same literal coefficients. We cannot add them if this one is b. So let's try an example. So we have 5x squared y z cubed times 4xy cubed z squared. So what we are going to do is we just multiply first the numerical coefficient, which is 5 times 4 is 20. And then we have our literal coefficient, which is x squared times x is x cubed, because we are just going to add 2 plus 1, which we have imaginary 1 exponent here. So next we are going to multiply y times y cube is y to the 4th power. And then z cube times z squared is z to the 5th power. Let's go on to another example. So we have the quantity of AB cube. So what we are going to do here is we can split them up to 3. We have AB times AB times AB. What do you think is the answer? The answer is A cube B cube. So let's have an example. So we have 3mn squared. So what we are going to do is we can split them up, which is 3mn times 3mn. And then we multiply them because there are two 3mn here because it's raised to 2. So we have 3 times 3 is 9. M times m is m squared. N times n is n squared. So the answer is 9m squared n squared. Let's go on to another case. So we have a squared cube, or the quantity of a squared cube. So what we are going to do is we have two. We can split them up, or we can just multiply this exponent to this one. So if we split them up, we have a squared times a squared times a squared, because we have 3a squared. So the answer is we just add them, which is 2 plus 2, 4 plus 2, 6. Or multiply, 2 times 3 is 6. So, a to the 6th power. Let's have some example. We have m squared, the quantity of m squared raised to the 4th power. What do you think is the answer? The answer is m squared times 4, which is m to the 8th power. Another example, the quantity of 3a squared b cube. So, what do you think is the answer? So, we can split them up or just distribute the cube. Equals, we can have 3 cube times a squared times 3b cube times cube. So the answer is 3 raised to the 3rd power, or 3 cube, is 3 times 3 is 9 times 3, 27. A, 2 times 3 is 6, so we have a to the 6th power. 3 times 3 is 9, so we have b to the 9th power. So our answer is 27, a to the 6, b to the 9. So to multiply monomials, multiply the numerical coefficients and follow the rules of exponents for the literal coefficients. What if we have this term a to the 5th power over a to the 5th power? What do you think is our answer? So if we expand them, it will be only just a times a times a times a times a. So we have 5 a's in the numerator. We have also 5 a's in the denominator. 5. So if we cross out each of them correspondingly, we will end to a result of 1. Let's move on to our next example. So without using the expansion, we can just simply subtract the exponent of the numerator over the denominator. So 8 divided by 2 is simply 4. And then let's go on here, times a, 5 minus 6, times b, 4 minus 6. So the result here is 4a to the negative 1, b to the negative 2. So if that's the case, we can write it as 4 over a b squared. As for our last example, we have the quantity of m squared divided by n cubed raised to the 4th power. We can simply distribute this first. So we have to multiply m squared times 4 over n cubed times 4. And then simply multiply them. So we have m to the 8th power over n to the 12th power. So that's all for today. Thanks for watching.